Hi Joe, I hope you're having a good summer. I put together a quick video to give you an idea where I'm at with the slide presentation for this show. You can see this title screen. You can go ahead and correct if you want to change the way you're titled in this. I'll give you the link in the email that I send you for the link to YouTube. Let's go ahead. I have to click on the screen to get it started. So I thought that we would introduce the paper, but not and review the paper, but not make that the whole presentation, because I've done some additional work, and I think that kind of gives it a trajectory that'll make the presentation a little more interesting. And then give the audience time for critique. I think we're supposed to present for maybe about 20 minutes, and then allowing some time for critiquing. And we may want to be shorter than that if we can open up a dialogue. So that's the idea. I've written some notes here, kind of talking about this idea of digital modeling as a way to enhance teaching. We're going to get onto that, I think, really with you, and the idea that digital modeling is sometimes the only way that we can model because of our limited access to materials and workspaces at schools that have limited access to these kind of things. I want to talk about how Revit isn't really a great modeler, but we kind of work to make it that way. Um, and then, more that we can talk about as we go through the slideshow. I want to set the context that the development of a lot of our courseware sits within this advanced structural concepts course, of which is evolving this facade tectonics idea, the idea of introducing rain screen, exploring embodied carbon, and the idea of things like unitized modular construction for both performance and cost-effective building. So our first paper was really the exploration of this idea of embedding large amounts of technical detail into walls. Typically, our BIM modelers are really simple in the amount of information that they contain, but in curtain wall systems, we have the ability to add a lot of rich information that can be really instructive to the student. And instead of asking them to actually construct this data from the first start, we kind of provide it for them in an order of a way to create a sense of quick engagement. So the idea here is the students can work creatively to create a facade for its aesthetic qualities, manipulating shapes of tiles, placements of windows, massing of wall systems, and then by revealing what's underneath, the technology is all coming along with it. They can gain a greater understanding of the impact of what they're doing. So a quick kind of animation of what's going on here. We start with a Revit model system, which is a curtain wall component, and we place that in a fashion on the screen or on a wall surface, and then we can actually control what the visibility is. So this is a full array of panels on the wall, but you don't see them yet because the panels are all hidden by creating a layer of turning on or off visibility. So just quickly, we start out with plywood. We add the moisture barrier by activating that layer. We activate the hanging system, the attachment system, the Z-girt in this case, in order to attach the track systems that will hold the tile. We place the insulation so students get an idea of its placement within the curtain wall system, what it looks like on a real building while it's going up under construction. Then we add the track or attachment system to the wall. And then finally, we add the tiles. And then by selecting which tiles are made visible, we can control the appearance of the wall system. So that's a quick introductory kind of methodology. And then this allows the student to go back and then create descriptive drawings like this that show the buildup of those complex wall systems. So this, as a part of the course, would run in 1 week, where they would get this assignment via a video instructional methodology. And this is an example of one of the students' projects that was rather intriguing. So there was a level of engagement in the creation of the shape of the tiles, use of color, and so forth. And then the idea of putting it together into a descriptive presentation that we're looking at. We critiqued the students or queried the students about the idea of what they thought about this. And the question was, rain screens have an impact on the design aesthetic of the facade. And we got a real high correlation, which was what I was hoping for, and maybe it was a leading question about that this was an important concept. The idea that placement of the window, the thickness, the way it looks, all the aspects of the tile and modularity of it. Some of the critiques coming back on us could be too much done for the learner on the first project, limited flexibility in the design, um, and alternately, obviously, the argument we're making is a simple and quick way to connect details with design to start off with. So once again, I mentioned that idea of course delivery. And Joe, this is where we start to get to this idea of accessibility. These are provided as a step-by-step YouTube video system that could be done remotely or enhanced levels of accessibility as long as they have access to a computer and the Revit, which would mean some kind of enrollment in an educational program. So we started with that, and that gave us, a base point for thinking about where we would go with further education in this. Obviously, that's a relatively simple project or exploration. And concurrently, at the same time, we were developing a facade exploration in our computer visualization course, which is an entry-level course, and kind of bringing that to thinking about how we're going to bring that together in a more advanced tectonic exploration for students going forward. And so in the computer visualization course, we start out, which is on the right-hand side here, with a simple wall, a punched wall, punched opening wall system with a tile created just as a Revit texture, helping them to get the idea of relationships of alignment to tile sizes. Then we look at creating thick wall systems and the idea of creating, the kind of massing that would go along with that. We look at double wall systems, a wall over a wall, in order to create a kind of hierarchy. And then as we move along, we've kind of discovered that actually windows can become the complete facade itself. So you're actually no longer completing and this is just in the technology of the BIM, you're inserting windows that have masses around them, which are the wall systems, but it's window next to window next to window. So you're actually not creating it's not a conventional way of thinking about the way we build up our facade systems. And this is just a really useful tool to help students get quickly into this idea of these punched facades that are really important for performance sake, because what we're doing is now we're starting to look at the glazing system is not a glass wall, but a wall that has, we can control the size of that aperture. So we start to look at creating just a simple window element, which we can add all kinds of columns, spandrels, and other elements in. And this was really a successful entry-level project. I want to take a mention this idea that this punched opening is a really important concept for us managing, our material usage, the performance of our curtain walls. And this is just one of those first ideas about what's important about this understanding, especially when we're making rain screen components. The gray illustrates our insulation on the outside of the building. The red is actually the wall perimeter. And the idea of where we locate that wall or glazing component with respect to that affects the energy performance of that wall. And Joe, this is a slide that's completely undeveloped, and even the concept of the slide could just be totally eliminated. So back to that idea of punched openings, and this kind of an introduction to Boston Valley Terracotta. This was a really, stimulating or exciting idea about where, traditional architectural facades are going. So the punched opening once again, but now with these beautiful expressions of terracotta extruded tile systems. And we have done some visiting to the Boston Valley Terracotta site. They're a sponsor of our trip here. You see the beautiful tile systems that they create. And this is a good stepping stone to our next level of project concepts. And that really is about helping students to see these ideas of punched openings in not even just in the total facade, but the idea of the facade mock-up. So this is the backyard of Boston Valley Terracotta and some of the mock-ups that they've created. And we're kind of using this as a stepping stone with the idea of creating our own kind of virtual mock-ups. And once again, to the idea of accessibility, students don't have access to making these real-world full-scale mock-ups. And so we're trying to move students into more accessible ways of building these things. So here we have on the left I guess that's a left to the viewer. I'm getting a little confused here. Left to the viewer, a virtual mock-up that we've created. and then the real world mock-up that a Boston Valley would create. And I think we can create really detailed learning experiences for the student. While not, while not of the fidelity of a real mock-up, there are a few things that really become apparent that once you start making these digital mock-ups are really useful. For instance, if we use Enscape and we use a VR headset, we can immediately immerse ourselves in this three-dimensional environment and get a really good feeling, like only VR can do, of the physical scale of the elements that we're creating. We can also start to explore this idea of modular construction. So because we're building up these mock-ups as simple assemblies of a few components, we can start to look at the elements that need to be considered when we start to build these up with offsite construction techniques. I still want to talk about this idea of making these complex assemblies because it's the introduction to the concept of the digital twin. Don't have a graphic for this, but I think it's really important to help architects become comfortable with this idea of a high level of detail in the componentry and the ideas that they're expressing, because they're going to create a very valuable model, that digital twin, which is part of the workflow and a part of the work product that architects of the future are going to be involved with. And then I have a couple of more details. These might fit into the slides, but the idea of looking at clip systems and attachment systems, starting to explore things like thermal breaks, which are the things that are indicated in red. And then this idea of the integration of different materials. So this is the attachment of a terracotta tile and an aluminum extrusion attached to the facade. So I think that's really about the length of content. A lot could be cut out. A lot actually needs to be fixed and enhanced and not stumbled over. But I think this is an opportunity for you to get involved to really help really craft this presentation, Joe. So let me know what you think. I look forward to it.